Hey guys, welcome back everybody. Hope you all are doing great. Guys, this is part 9 of this topology configuration. If you have not watched the previous videos, then please start watching videos from day 1 from part 1 where we have discussed the configuration of all devices in detail. Now this network is live. That means all the end devices are able to access internet as well as internet is able to access my internal server. Like you can see I have two server here, server 1 and server 2, and we are running many protocol here like HSRP protocol. We are performing load balancing between distribution layer switch 1 and distribution layer switch 2. You can see the SVI configuration on switch 1 and switch 2. Then the DHCP is running, right? We have some management PC here, and through this management PC I'm able to access all these devices through SSH, and the username for SSH is admin and password is pmnet@123. For the security we have configured the enable password which is cisco@123, and on the line VTY you can see this password. On the line console also we had configured the password, right? So all the protocols are already configured here, right? If you want to watch videos from part 1 from day 1 here on my YouTube channel, you can check this playlist, right? Here you can see name of the playlist is real time network, right? And 8 videos are there guys, and this one is the 9th video. Once I will add this video here in the playlist, you will see total videos are 9. And today we are going to focus on the improvement section, right? Now we are done with the configuration, right? There is connectivity with the help of routing protocol. We are running OSPF here between core layer and distribution layer. In this section I think I am running OSPF area 0, and here we are running OSPF area 1. And today we are going to work on the improvement, right? How to improve the performance of this network, right? Guys, whatever configuration we have covered here in this topology, those all are based on real-time network only. In the same way we are configuring the real-time network. So once you will done with the connectivity, you are going to start working on the improvement section, right? How to improve the performance, like how to reduce the size of routing table of router, firewall, because here you can see I have one firewall, and guys this firewall is for security, not for the routing, right? So we will not install lots of routes in the routing table of this firewall, ASA firewall. We have one router here for the routing purpose, right? So this router is responsible for internal as well as external routing. Okay, after that we'll see the HSRP improvement, like if we can enhance the like the failover between distribution layer switch 1 and distribution layer switch 2. Then we can improve the failover between ISP1 and ISP2, because here in my scenario ISP1 is the primary ISP and ISP2 is the secondary ISP, right? So until and unless ISP1 is up, all the user will access internet via ISP1. If ISP1 goes down, then automatically ASA firewall will shift the traffic towards ISP2, and if there is some delay, then we'll try to reduce that delay, how quickly ASA firewall can shift the traffic from ISP1 to ISP2. And later we'll work on the more improvement guys, like how to achieve load balancing between these two ISP, how to configure the how to advertise like the internal subnet to the global internet. And after that we'll see how to configure the scenario if we have multiple sites like this which are connected with the different transportation network, or you can say with the WAN circuit like the internet and MPLS. Okay, so today our agenda is to work on the improvement inside the LAN for the LAN users. So without wasting our time, let's begin. So guys, first of all, let's verify the previous configuration. For that I am going to access any PC. Let's say PC1. PC1 is in VLAN 10, right? Even here you can see PC1 is in VLAN 10. Here all the devices, right? And for VLAN 10, my switch 1 is the active switch in HSRP, right? So, and switch 1 is the even DHCP server. So let me try to get IP address from the DHCP server on this PC. For that I will run command IP DHCP here. And you can see This machine have got the IP address 192.168.1.1. Now let me try to ping 8.8.8 internet directly from this PC, or even you can see the gateway IP address, which is the IP address of switch 1. You can ping to gateway 192.168.1.100, and you can see I am able to ping my gateway. Now I am going to ping internet directly 8.8.8. I think ping should work because we had already configured the NAT or everything on the edge router 8.8.8, and you can see I am able to ping 8.8.8. If you want to check I am able to ping 8.8.8 internet via which ISP, ISP1 and ISP2, you can trace route. I can say trace and then 8.8.8, but I think firewall will block the trace route. I had only allow ccnp protocol on ASA firewall and HTTP, so we cannot trace route. Trace route is not going to work. Trace route can track up to ASA firewall only. So we can do one more thing here. I can access my ASA firewall, and here I can enable the debugging, or I can check the routing table to find the default route. So default route is towards ISP1 and ISP2. So guys, you can see I have access of my ASA firewall. If I will run enable command, it will ask for the password, and enable password is Cisco @123. So Cisco @123. Now I have access of my ASA firewall in enable mode. Here I can run command show route, and then I can say include 0.0.0. So you can see default route is present in the routing table towards ISP2. That means maybe ISP1 is down now. That's why default route is pointing towards ISP2. So I can do one thing here. I can run command show interface IP brief, and you can see fast G0/0 is connected with ISP1. So G0/0. This interface is, guys, administratively down. That's why ASA firewall is forwarding traffic towards ISP2. Let me up this port. Here I am going to say config t and interface G0/0 and say no set here, right? On this port will come up, your track will come up. We are using track to track the ISP, correct? And with the help of IPSLA. So even you can run command show track here, and you can see your track is down. So it is taking some time, right? So here you need to work for the improvement, so that how quickly ASA firewall will shift traffic towards ISP1. Done, guys. Let me check again. So track, still track is down. Until and unless track will be down, so route, it will be using default route towards ISP2, include 0.0.0. You can see now it have installed default route towards ISP1. That means your track is now up. Yes, you can see track is up now. So that's why it have installed default route towards ISP1. Now still you can see PC1 is able to ping internet, right? And this time PC is pinging internet via ISP1. We can do one more thing here. We can enable debugging for the NAT, debug NAT, or I can say 255, and after that you can ping. So you can see it is translating the source into 1.1.1, which is the IP address of G0/0 of ASA firewall, right? Between ASA and ISP1 I am using this subnet 1.1.1.0/24, and between ASA and ISP2 I am using this subnet 2.2.2.0/29. Done. Now what will happen if ISP1 will goes down again, guys? Let me do one thing. Let me keep sending ICMP packet, and you can see ASA firewall is translating. Now I am going to down ISP1. Let me check how many packet will get dropped. Here you can see now I am getting the packet loss here, request timeout. And on the ASA firewall you can see the reason ASA firewall is still translating source into 1.1.1.1, which is the IP address of G0/0, right? Let me say all here and show track. So you can see your track is still up, right? So here also we need to work on the improvement, or maybe in track I am tracking this interface. Like I can check show run track. Here in the track I am using SLA1. So SLA monitor and then we can see the configuration. I can say it will show me the configuration. So see, I am tracing this public IP address, right? 1.1.1.6, which is the IP address on ISP router. So track, guys, again. Now track is, you can see down, and it's again my PC is able to access internet, right? So there was some packet loss here. Lots of packet loss was here. You can see around 20 to 30 packet was dropped. Here you can see the packet loss from here to here, right? But after that, ASA firewall has shifted the traffic towards ISP2. Again, when ISP1 will come up, ping is working, and let me up the ISP1, again you will get maybe some packet drop. On stack will come up, ASA firewall will shift the traffic towards ISP1, right? So everything is working fine. Now guys, the agenda of today is improvement. How to improve the performance? See, we will work on this improvement, like it is taking some time later, not today. Today we are going to work on the routing table or in the LAN side improvement, right? So on all, here I have disabled the debugging, and so track, again your track is down, so it is forwarding traffic towards ISP2 only. After some time maybe track will come up if this ISP is, yeah, this ISP is up now, right? Okay, leave it. Now let me show you one thing, the routing table of ASA firewall. Let me show you the routing table of ASA firewall. So IP route, so sorry, route. So guys, see the routing table of ASA firewall. These are the directly connected subnet, and we cannot reduce this subnet. But see the OSPF route. These are, right, the route of OSPF. This ASA firewall is learning from OSPF protocol, and here you are able to see this subnet like 192.168.0.4. This is not the user subnet, guys. This is the subnet between distribution layer switch 1 and my core router, this subnet, right? After that, ASA firewall have this subnet also. If you have two subnet here, if you have multiple subnet here, let's say between this distribution layer switch 1 and distribution layer 2 switch 2, also we have one subnet. So ASA firewall will have one entry for these all subnet, for all the internal subnet. After that, they have installed the subnet for all the VLANs, right? Like 192.168.1.0 for VLAN 10, 2.0, 20, 30, 40, right? As I told you, ASA firewall is for the security, not for the routing. So if you will reduce the size of routing table of ASA firewall, automatically performance will enhanced here, right? Performance will be better. Now question is how to reduce the routing table size of my ASA firewall. So guys, see, we have multiple options. We can configure the route filtering here. We can configure the route filtering either on router number 1 or on ASA firewall. So to configure the route filtering only, I have divided the OSPF into area. Earlier, these all devices was in same area, in area OSPF area 0. But now I have placed ASA firewall and my core router in area 1, and this domain in area 0, or you can put this in area 0 and this in area 1, right? So if you have divide the OSPF domain into the area, now you can configure the route filtering here on router number 1. We can configure the summarization. Even see, if you will configure the route filtering, there will be some issue, like if this PC, this management PC will try to access the ASA firewall, they will ping to, they will access this ASA firewall with this IP address 192.168.0.2, right? So there should be route in the routing table of my core router, and ASA firewall should also have route, right, to generate the reply message. So instead of route filtering, we can configure summarization here. We can summarize all 192.168 1.0, 2.0, 3.0, 4.0, or 0.4, 0.8, these to a single subnet, which is, let's say, 192.168.0.0/16, right? So if I will summarize these all subnet, all your internal subnet will match in this summary address, right? And then ASA firewall will only install this summary address in their routing table, right? Like on ASA firewall, if now I will show you the OSPF routing protocol here. I can run command so route OSPF here, OSPF. So see the OSPF routing protocol. There are lots of prefixes, right? Even this topology is very small. In real time, you will have large topology. You will have lots of internal subnet, right? So if ASA firewall is going to store lots of subnet in the routing table, routes in the routing table, performance can get reduced. So the other option is, guys, summarization. On my is router, we can, on the core router, we can perform summarization. For that, definitely you have to find the border router, right? So here I can say OSPF. So OSPF, let's say border router, right? So border router is 192.168.0.1, which is the IP address of my core router, right? So on core router, guys, on the core router, let me access my core router R1. And this core router, I am going to say so IP, sorry, first enable password, which is Cisco @123. Now you can see I have access of my core router. Here I am going to say so IP protocol. It will show you this is an area border router. You can see it is an area border as well as autonomous system border router, right? So on this router we can perform the summarization, right? So for the summarization, guys, let me do it. Say router OSPF 1. I think I'm running process ID 1 only. Yes, 1, right? And one more thing I need to verify here. Do so IP OSPF interface brief. See, fast Ethernet 0/0 is connected with ASA firewall, and guys, fast Ethernet 0/0 is in area 1, and these two interface F1/0 and F2/0 are connected with distribution layer switches. So area ID of on these interfaces is 0, right? So this is my area 0, and this is between ASA and core router area 1. So I am going to summarize the route for area 0. So I am going to say area, let's say 0, and then say range, and after that the summary address 192.168. Let's say 0.0 subnet mask 255.255.0.0, right? Once I will advertise it, or I can say advertise summary only, advertise summary only. Here somewhere you will get that option also, or not advertise like that. You can even change the cost, those things. Those are again the part of improvement only, but for now I am using everything default, right? This command only. After running this command, if you will check the routing table of ASA firewall, like OSPF routing table of ASA firewall, you will see there is only one route subnet. Earlier lots of subnet was there, right? Now again I am going to run command so route OSPF, so route OSPF. Now you can see it is there is only one route in the routing table of ASA firewall, right? And all the internal subnets will come under this entry, under this subnet, because this is the summary. So guys, this was one improvement to reduce the size of routing table of ASA firewall, and still you can see my PC and devices are able to access internet. Getting my point? Even PC2, 2 PC, 3 PC, all PC can access internet at the same time. Here also I am saying IP DHCP to get IP address. I think this PC belongs to VLAN 20. Let me check that. Even here also you can see PC2 is in VLAN 20, so that's why this PC have got the different IP address from the different subnet 2.1, right? And ping 8.8.8.8-T. So yes, you can see PC1 and PC2, both machines are able to access internet, both are keep pinging to ISP internet, right? And we have reduced the size of routing table of ASA firewall. So this was one improvement. Like this, you can summarize the route on distribution layer switch 1, distribution layer switch 2, as well as on core router. Even if you want to filter the route, you can filter as well. You can configure the filtering, right? Like, you know, distance 255 option is there in OSPF to filter one route. So for a specific route, I can configure distance value 255, do so IP route OSPF, do so IP route OSPF. So you can see the routing table of OSPF on core router. If you want to filter any prefix, you can filter. You can simply configure the distance 255 for that. And there are many more options are available for the route filtering. As you have configured the summarization here, it have installed one entry for the loop avoidance with null zero interface. Done. Now guys, see, PC1 is able to access internet, and let me check, let me check let me do one thing. Let me down distribution layer switch 1. See, I don't have any redundancy for the core layer, right? So in the improvement section, we can add redundancy here as well at the core layer. We will see those improvement because those are the, you know, big improvement. So we'll work on those improvement later. First, let's work on the small improvement, right? So at distribution layer, we have redundancy. We have distribution layer switch 1 and distribution layer switch 2. So let me try to check that failover is working or not at distribution layer. What I am going to do, I am going to down distribution layer switch 1 and see the PC1. Now PC1 has start getting packet loss, 2 packet loss, 3 packet loss, 4 packet loss, 5 packet loss, and after that again it is able to access internet, right, through distribution layer switch 2. So failover is working fine, right? But the 5 packet is getting lost. 1 packet is 2 seconds. That means there is outage for 10 seconds. So even we can reduce this timer in HSRP. This is just because of HSRP hello time and dead time. It is taking 10 seconds. So to reduce it, what we can do? First of all, let me turn on this device again, and again let me check it is shifting traffic on distribution layer switch 1 or not. So yes, now you can see, I think traffic has started moving through distribution layer switch 1, right? Now I'm going to access this distribution layer switch 1. See, the 1 packet loss is there, right? Now the traffic is shifted on distribution layer switch 1. So when the primary switch is coming up, that time we are getting 1 packet loss, and when primary switch is going down, that time I am getting 5 packet loss. I'm talking about the ICMP packet, right? So to reduce this, what we can do, we can modify the HSRP timer, right? Whatever protocol you are running, if you are running HSRP, then HSRP. If you are running VRRP, then VRRP timer. So enable password is Cisco @123, and again here I am going to take PC. Done. And now let me check the standby configuration. So standby for VLAN 10. For VLAN 10, you can see this switch is the active switch. This switch is the active gate, and the virtual IP address is this one, which is the gateway IP address for PC. And guys, hello time is 3 seconds, hold on time is 10 seconds. So this was the reason, right, why I was getting 5 packet loss, right? So if the hold on time is 10 seconds, so you will get outage for 10 seconds. So we can reduce it. We can reduce it over here, interface VLAN 10, and then I can say IP HSRP or standby. I think not IP, only standby, and then group number. What was the group number? Let me check that also. Group number was 1. So say 1 and then say hello, or I think timer, right? Now it is asking for the hello time. Let me say hello time 1 second, and hold on time, let's say 2 seconds. So you will get only 1 packet loss now, right? Again, if I will down this interface, say shut down, you will see the 1 packet loss here, you can see, and after that you can see again traffic is going via distribution layer switch 2. So now I will get only two packet loss here. Even we can do same thing for VLAN 20 and 30 as well. I can use range command, interface range VLAN, interface range VLAN 10, VLAN 20 and VLAN 30. So it will reduce the outage time, but it will be sending lots of hello message. So guys, it might be possible that performance can get reduced of these switches, distribution layer switches, right? So you have to work on these things very carefully, right? Here I am going to say standby and the hello, sorry, timer 1 second, 2 second, hold on, time 2 second, then I can say right. You can check the CPU utilization of this device as well by running command show process and CPU. So CPU utilization is, now you can see the 0% in last 5 seconds, in 1 minute also 0 second, in 5 minute also it is 0 second. The average CPU utilization is 0 second. So we can do it. We have the CPU here, correct? But it might be possible it's showing 0% because of simulation. In simulation, in the real network guys, you will see the CPU utilization is maybe 40%, 30%, and make sure CPU utilization is below 70% for the better performance. If CPU utilization is more than 70%, then performance can get reduced, right? So this was the second improvement here in this scenario. We can do same thing on distribution layer switch 2 also. Enable Cisco @123, enable password, config T, interface range VLAN 10, VLAN 20 and VLAN 30. Say standby, timer 1 second, 2 second, write the configuration, right? So like this you can improve the configuration of this topology. So guys, today we have seen two improvement here. One, we have reduced the routing table of ASA firewall, and one, we have changed the HSRP hello and hold on timer. In next video we will work on more improvement in this scenario, right? So keep watching and keep watching in the sequence, right, to get everything of the real-time network configuration. Later we will be adding more devices here at this core layer, or I will make one another playlist for that scenario. If the scenario is different, then we'll see the configuration from zero in the different scenario. And guys, at the last of this series we will have multiple sites like this which are connected with the internet, and then all sites will be able to communicate with each other, as well as all users will be able to access internet, and internet will be also able to access your internal server. That's all for today guys. If you have learned something from this video, please hit on like button. If you have any query, concern, please let me know in the comment section. If you have not subscribed this channel till now, please subscribe this channel. We'll meet soon in the next video. Till then, stay safe. Bye bye. That's all for today.